In section 3.4, we also talk about the rational zero test. In this test, it's kind of something I call mind your P's and Q's because you're dealing with P's and Q's in this one. And basically, it's saying that you're going to factor everything that's in this very last constant. You're going to factor it down. Those are your P's. And here, the first one, those are the Q's. When you factor them down, you will then put every possible combination of P over Q to find possible rational zero that is somewhere inside the polynomial. Let's look at how that looks. Here I have a P of 6 and a Q of 1. So let's write down all the possible factors of 6. So with this, I'll have 1 and 6, so I can have a plus or minus 1, a plus or minus 6. I also have factors of 2 and 3. For the Q, this one's super easy because I have only one number. It is a 1. So all of my possible zeros are going to be combinations of P over Q. So I could have, let's write this out. I could have 1 over 1 plus or minus, which is a 1. And then I could have 6 over 1, which is 6. I can have 2 over 1, which is 2. And I can have 3 over 1, which is just 3. So I have 4 possible zeros, and those can be further tested out. By applying synthetic division, I can actually determine which ones are my zeros. I could take the -1. So let's go back for a second. Notice that I have 4 plus or minus, so I actually have 8 possible zeros. Just go back for a second. So I could have a positive or a -1, a positive or -6, and so on. So on this one, we are testing -1. And so if you notice that we put it through and we end up with 0 as a denominator. So we do know that -1 is a 0 of the polynomial using synthetic division. I do have a video on synthetic division from 3.2 if you need to go back and review how to do that. So we find out that there are 3 zeros. We have x plus 1, x minus 2, and x plus 3 as our zeros for this situation. So on this one, when you have x squared plus 3, those are not real zeros, but these two are. So if I go to graph them, I know that it crosses the x-axis at -1 and at 2.